So we got a hyperbola. We need to find the center of that hyperbola. We're given these two vertices. So all we have to do is find out what these two vertices are in Cartesian coordinates. And then we can just find the average between the two, and that'll be the center that we need. Right now they're in polar coordinates. So to convert from polar to Cartesian, we can just use these formulas. So r is 1/6, theta is 0. So 1/6 times cosine theta would be our x-coordinate. So this is going to be 1/6 because if you plug in 1/6 in for r and 0 in for cosine, cosine 0 is 1. 1 times 1/6 is 1. Then same thing for the y-coordinates. If you plug in 1/6 for r, 0 for theta, sine of 0 is 0, so this makes 0 for a y-coordinate. And then here's the polar coordinate. We need to convert it again. So if you plug in -1/8, plug in pi for cosine. Cosine of pi is -1, so -1 times -1/8 is 1/8. And do the same thing over here, but sine of pi is 0. Those are those two vertices that we were talking about. And we've got a hyperbola. There's one at 1/6, 0. This is this one. And there's one at 1/8, 0. So the center is going to be exactly between those two. We know the center is going to have a coordinate of 0, because if this is 0 for y, 0 for y, then the y coordinate is 0. The center is just going to be the average of the two. So we just got to compute 1/6 plus 1/8 and divide that by 2. So that's 8 over 48. Wait, 8, 2, 40, 40, yeah. 8 over 48. This is 6 over 48. That's 14 over 48. And then divide that by 2, so that's 7 over 48, I think. This question's a bit trickier, though, because they just said this is just a conic section. They didn't tell us that it was a hyperbola, didn't tell us the vertices, so we got to find those. We got to find the vertices ourselves for this one. Okay, so we got to put it in standard form. The polar equation of a conic section, the focal parameter p and eccentricity e is given by either these two equations. So look, there's a 1 here. We can't have an 8. We've got to rewrite a little bit by factoring out an 8 from the denominator. It's 4 over 8. And then it's 1 minus, we need 9 over 8 to compensate. So that if we were to distribute that 8, it would turn back into the same thing. Okay, so now we can identify what, well here, this is 4 over 8, so that is 1/2. So we could put 1/2 in the numerator, because we need to have we need to just have 1 in the denominator. So 1 minus 9 over 8 sine theta. Right, because 4 over 8, that's 1 over 2. In other words, that's 1/2 in the numerator, because if you were to divide these two fractions, you'd flip and multiply. So bring us back to where we are. So E is 9/8, and we can identify P from that by just doing a little bit more rearranging. We need this to equal, the top needs to be E times P equals 1/2, so that we have this form, right? The numerator needs to be E times P. So we've got 1/2 right now in the numerator. We know what E is, because in the denominator, E is 9/8. So to get P by itself, multiply both sides by 8/9, so you get 8, those would cross simplify. 8 over 18, which is 4 over 9. So that's what P has to be. So we got it all, we can put it all together. That's, we got 4/9 times 9/8, 1 minus 9 over 8 sine theta. Okay, so that's the first part of solving this problem, is getting it in the standard form. Once you have it in standard form, we have these rules. If E equals 0, the conic section is a circle. If it's between 0 and 1, it's an ellipse. If it's equal to 1, then it's a parabola. And if it's greater than 1, E tells us that it's a hyperbola. So we got 9/8 for our E. So we know we're dealing with a hyperbola now. Now that we know it's a hyperbola, Newton spells out these rules for us in the description of the answer for these types of problems. We have sine in the denominator. So if you look at this list of rules, it says sine is the denominator, then a conic's major axis is vertical. Its vertices occur when theta equals pi over 2 and when theta equals 3 pi over 2. So that means to find the vertices, we got to plug pi over 2 in for theta and 3 pi over 2 in for theta. Okay, so we got our equation for the circle. To find the vertices, we got to plug in pi over 2 and 3 pi over 2. But we know in polar coordinates, vertices occur at pi over 2 and at 3 pi over 2. Because those are the thetas where it tells us, it spells it out because we have a hyperbola. And then we need to plug in these vertices into the equation and simplify. So if you plug in pi over 2 in for sine, that's 1. Because remember, sine are the y coordinates in the unit circle. The unit circle is just the circle with a radius of 1. So pi over 2 is a 90-degree angle, so that's 0, 1. So that's, and sine is always the y coordinates. There's probably different ways that teachers teach that, but if you plug pi over 2 in for sine, it gives you 1. That's the long and short of it. And so if we simplify up here, those cross simplify, so that gives us that 1/2 we had. And we got 1 minus, sine is 1, so that's 1 minus 9/8. So it's negative 1/8 in the denominator. So 1/2 divided by negative 1/8, that's negative 4. Did that kind of quick in my head. Just double check me. 1/2 divided by negative 1/8. That's 1/2 times negative 8 over 1. So that's negative 4. And the same thing, plug in 3 pi over 2. If you do that, sine of 3 pi over 2 is negative 1. So you're going to have negative 9/8 times negative 1 gives you positive 9/8 plus, so that's 1 plus 9/8 in the denominator. So that's 17 over 8 in the denominator. We got 1/2 still in the numerator. So if I plug in 3 pi over 2, I'm getting 4 over 17. So those are the points for our two vertices for our hyperbola.